Hi. In our last video, we were discussing Stokes-Samuelson effect. What we did in the last video was that we were able to express rewards to factors of production, wage and rent, as functions of prices of final goods, food and manufacturers. Now we will discuss something called John's Magnification Effect. Look, very often in economics it is very hard to establish some relationship in terms of levels. So in terms of wage in this case, and rent, and prices. But when we look at relative changes, it turns out that those relationships are becoming extremely easy. Okay, so what will we understand by relative change? Well, relative change in wage, so wage W tilde is given as dW, so very small change in wage divided by wage. And look, by the same token, we see that relative change in rent is dr over r. Relative change in price of manufacturers is given by dPm over P of manufacturers, dPm, and relative change in price of food is dPf over Pf. And now look, what we're going to do now is to figure out how those four relative changes are connected to one another. Okay, so let's start with wage. And let's notice a very simple thing, that in this case, wage can be thought of as some function of price of food and price of manufacturers. Okay, we know the specific, of course, form of the function, but let's start with more general approach. Remember that here we have the constant that is made out of alpha m and alpha f with different configurations. But what we know is that this is definitely some positive number, and it's a constant number, of course. So the rest we need to do is to deal with effect of Pf and Pm on W. And we can do it again by resorting to differentials. Because look, we get that dW, so differential of W, change in W, can come from two sources. First, it can come from change in price of food, and how does price of food affect wage? Through partial derivative dW dPf. And the second source of change comes from change in price of manufacturers. And how does price of manufacturers affect wage? Well, through partial derivative dW dPf. Okay, so look, basically, all we've got to do right now is to calculate this expression, then divide both sides by wage, and we will get expression for relative change in wage. Okay, so let's do it. So we get the dW is equal to, okay, first we need to calculate this derivative. Okay, so because we differentiate with respect to price of food, so this power goes up front, right? So we get alpha m over alpha m minus alpha f. Then this expression stays the same. This is a constant in front. So we've got Pm to the power minus alpha f over alpha m minus alpha f minus 1, right? Because this is the power. Oh my god, no, sorry, we are differentiating with respect to price of food. I should start with this. Price of food, alpha m minus alpha f minus 1. And then this expression stays exactly the same because we keep it constant. Right? So we've got alpha f over alpha m minus alpha f. Okay, then we need to add, and of course this whole thing multiplied by dpf. Then we need to add another component, of course this part. So we need to now differentiate wage with respect to price of manufacturers, right? So this again goes up front. So we will have minus up front, alpha f, alpha m minus alpha f, like this. And then again we will have gamma w. Now this stays the same, we keep it constant, of course. Over m minus alpha f. We need to then take this expression, Pm minus alpha f over alpha m minus alpha f minus 1. And of course, at the end, we would have dPn. Okay, so now we are halfway done. In the next step, we are actually able to calculate the relative change. How will we do it? Well, this is quite easy. As I said, all we need to do is to divide both sides of this equation by w. So, over here, we get that the relative change in wage defined as dw over w is equal to. And look, because we are dividing by w, we can just simply divide both of these components separately, right? So, over here, we're getting alpha m over alpha m minus alpha f, gamma w, EF. Of course, now we need to just rewrite this part. Alpha f minus 1, and then times Pm to the power negative alpha f over alpha m minus alpha f dpf. Okay, and of course we divide it by this expression. So we put here gamma w pf alpha m over alpha m minus alpha f times Pm to the power negative alpha f over alpha m minus alpha f. Okay, now we need to do the same thing with the second expression. So we keep the minus here. And we've got here alpha f over alpha m minus alpha f gamma w pf alpha m over alpha m minus alpha f Pm to the power negative alpha f over alpha m minus alpha f minus 1, and this whole thing times dPm. Okay, well, now of course we need to divide it again by wage. Okay, this looks really complicated, but as you can hopefully you can see right now, these two expressions are very similar. So we can expect a lot of the expressions would cancel each other out. Well, definitely over here, gamma w can be eliminated right away. Now, let's see over here. Here we have pf to the power alpha m over alpha m plus alpha m minus 1. And here we have pf to the power alpha m over alpha m minus alpha f. So look, those again cancel each other out. And the only thing that we've got left here is pf to the power negative 1. Which means the price of food will just go to the denominator. And again, those two cancel each other out. Now, moving to the second expression, we see that here we have two identical expressions. They cancel each other out. And again, we have a situation that those two cancel each other out. And again, now price of manufacturers is going to the denominator. Okay, so I hope you can see at this moment that things actually gotten way simpler. So how simple did they get? Well, over here you will have dw over w equals. Well, this part over here remains. So we've got alpha m over alpha m minus alpha f. But now look, the rest is almost entirely gone. There's only two things that are left. D, pf, and pf in the denominator. Then we've got minus this expression. Now we've got alpha f over alpha n minus alpha f. And what here is left? Here we have pm in the denominator and dpm. So we've got dpm over over p. And look, from this we get our first relationship that will allow us to elaborate on John's magnification effect. Because look, out of this we get that the relative change in wage is equal to alpha m over alpha m minus alpha f times a relative change in price of food minus alpha f over alpha m minus alpha f times relative change in price of manufacturers. As you see, this relation is extremely simple. And look, it actually works exactly as we predicted before. Because we see that the price of manufacturing going up clearly translates to wage decreasing, while price of food translates to wage increasing. And we remember, food uses labor extensively. Manufacturers are using capital extensively. So we clearly see that that relative change in price of food will increase in price of food will favor wage, while increase in price of manufacturing will decrease wage. Okay, so now when we understand the logic of the entire process, we can very easily repeat the same exercise for rent. So, look, we see that here calculate total differential, and then we get that this is d r d p n d p m plus d r d p f d p f. Okay, and now look, all we've got to do is to of course, rent. I'm sorry. Now, again, we need to calculate this differential first. So, we need to now differentiate this expression first with respect to price of manufacturers. So again, this goes up front. So we get that this is 1 minus alpha f over alpha m minus alpha f. We will write gamma r, and we've got pm to the power 1 minus alpha f over alpha m minus alpha f minus 1 times pf to the power negative 1 minus alpha m over alpha m minus alpha f d p m. Now we add the second part, but again, look, here we differentiate with respect to price of food. So this power is going up front. We've got minus up front, so again we can change this to the minus, and we get that this is 1 minus alpha m over alpha m minus alpha f. This part of course stays the same. Pm expression with Pm also stays the same. And finally, over here we just need to subtract 1 from the power. Okay, and now, again, we can calculate relative change in rate as dr over r. Okay. Oh, this is going to be, again, very time consuming, so let me just do it pretty fast. Well, first, we just rewrite this expression over here. Okay, and I got here 1 minus alpha f over alpha m minus alpha f gamma r pm 1 minus alpha f over alpha m minus alpha f to the power minus 1 times pf to the power negative 1 minus alpha m over alpha m minus alpha f d p m. And we divide it by rent. Okay, so now we need to deal with the second part. So again, we rewrite this expression. So we got 1 minus alpha m over alpha m minus alpha f gamma r pm to the power 1 minus alpha f over alpha m minus alpha f times pf to the power negative 1 minus alpha m over alpha m minus alpha f minus 1, and then we need to divide by rent. And of course, at the end, we've got DPF. Okay, and again, a lot of things here will simplify. Those two are definitely gone. Those two, those two are canceling each other out, and those two are canceling each other out. And look, here again, those two cancel each other out. The only thing left, we've got Pm to the power -1, and over here, those two cancel each other out, and we've got Pf to the power -1. So, what have we established now? Well, as you might expect, we get that the relative change in rent is equal to 1 minus alpha f over alpha m minus alpha f times dpm over pm, so relative change in price of manufacturers, minus 1 minus alpha m over alpha m minus alpha f. Then we just got dpf over pf, so relative change in price of food. And this is how we established the second relationship. The second relationship states that relative change in rent is equal to 1 minus alpha f over alpha m minus alpha f p m minus 1 minus alpha m over alpha m minus alpha f p relative change in the price of food. Okay, I know that was very time consuming, but now that we have proven that those relationships hold in neoclassical framework, they bring actually a very powerful conclusions for the entire book. Okay, I don't think we will need any of those anymore, so let me just clear the entire board. Okay. And now look, let's consider first a case like this. Price of manufacturers is going up, while price of food stays at the same level. How can we write this? Basically, this means that PM is positive, and at the same time, price of food, relative change in price of food, is equal to 0, which means that this price stays the same. Okay, and it turns out that in this particular situation, what happens? Rent. Look, what do we need to use out of these relationships? Well, definitely PMs are changing, PFs are zeros, so this is gone, but wage and rent will change. But let's see how will it change. Okay, and because I already know the result, I'm gonna give you the correct result right away, but I will also demonstrate why it works like this. Okay, so look, what do we have over here? Here we have the relative change in rent, of course, from this is equal to 1 minus alpha f over alpha m minus alpha f times relative change in price of manufacturers. This, as I will show in a second, is definitely bigger. It's bigger than relative change in price of manufacturers. This, in turn, is going to be bigger than change in price of food, which we assume is 0, and this will necessarily be bigger than definitely bigger than relative price change in wage, which is equal to negative alpha f over alpha m minus alpha f. Okay, now, actually, I'm gonna those relationships definitely hold. Look, what we see over here is that if price of manufacturing is rising, what price of food stays at exactly the same level, what is happening? Wage is negative, right? Relative change in wage is negative because this is a positive fraction. This is a positive fraction as well. How do we know? Because we are assuming that alpha m is bigger than alpha f because production of manufacturers is more capital intensive than production of food. Then this definitely needs to be smaller than 0 because this is a negative number, right? And we are assuming that the price of food now is staying exactly at the same level. Then we've got PM. So we know that this is positive. So how can we be sure that change in rent is going to be bigger than change in the price of manufacturers? Well, this requires a very simple condition to be satisfied. This needs to be bigger than 1. And actually, as it turns out, it is really easy to prove that this actually is bigger than 1. Okay, because look, 1 is definitely bigger than alpha m, right? Because alpha m is somewhere between 0 and 1. Right, now, I can take this inequality and subtract alpha f from both sides. Right? Now, if I divide both sides by alpha m minus alpha f, which is bigger than 0, I will receive and this is how we get the magnification effect. Magnification effect shows us that because this expression is bigger than 1, we clearly see that the change, the relative change in price of manufacturers is actually magnified by the value of this expression in rent. So, assuming that this expression is equal to, let's just say, exactly 1.5, this means that if price of manufacturing increases by 1%, then rent increases by 1.5%. Okay, now this is the first. So now we've established what happens if price of manufacturers is going up while price of food stays the same. Now what we need to do is to reverse this situation. Okay, let me erase that. Okay, so now we will assume that price of manufacturers stays exactly at the same level while relative price of food is going up. Okay, so this time the following relationship holds. The relative change in wage equal to alpha f over alpha m minus alpha f times p f is bigger than relative change in PF, which is again bigger than relative change in PM, which is equal to 0. And finally, it is definitely bigger than the price, than the rent, the relative change in rent, which is equal to negative 1 minus alpha m over alpha m minus alpha f times relative change in price of f. Okay, again, this part really easy because this is somewhere between 0 and 1. This is somewhere between 0 and 1. We get a positive number here with minus up front. This expression is negative. But this is, as we said, Stockler-Samuelson effect. Simply because we know that increase in price of food should favor wage while should diminish rent. And this is what happens. Of course, remember, this is what is happening in the long run equilibrium. Okay, so now we know that this is definitely lower than 0. And because we've assumed that this price of food, changing price of food, relative change is positive, we know that this is bigger than 0. And now the only thing we need to establish is whether relative change in wage is actually bigger than relative change in price of food. Again, we just need to prove that that this expression is bigger than 1. Okay, how do we do it? Look, we can do it very easily like that. Alpha f, as with our assumptions, definitely bigger than 0. But look, this also means that 0 must be bigger than negative alpha f, right? Now, what I can do is I can add alpha m to both sides of the equation. I can divide both sides by alpha m minus alpha f. And again, we can see that this expression is clearly bigger than 1, which tells us that actually increase in price of food will be magnified in wage. Okay, so now that we've proven everything, we can move to John's magnification effects. Okay, and John's magnification effects can be stated like this. In a neoclassical framework with two final goods, of course in our case those are manufacturers and food, and two factors of production, in our case capital and labor, with factor rewards, wage and R, respectively, changes in the final good prices are magnified in the factor rewards. So look, what are we getting from this? Look, if relative change in price of manufacturers is higher than relative change of price of food, this means that the relative change in rent is higher than the relative change in price of manufacturers, which is higher than the relative change in price of food, which is higher than the relative change in wage. And of course it works in the opposite direction. Right? Now, if relative price of M is increasing, manufacturers is relative change in the price of manufacturers is smaller than the relative change in the price of food, then we see that relative change in wage is the highest, is bigger than relative change in the price of foods, which is bigger than relative change in price of manufacturers, and this is bigger than the relative change in rent. Okay, so look, we can actually use Jones' magnification effect in some other context, actually in context of Rybczynski proposition, that we're gonna deal with in next video. But look, you can think about it as an extension of Stokes-Samuelson proposition over here, because now we see, like, actually the dynamics of what is happening in the model. As long as price of manufacturers is rising faster than the price of food, then rents are going to be rising faster than wages. And it also works in the opposite direction. Okay, I know that was a lot of mathematics to get this result, but thanks to what we've done here, we will not have to do it again when we are going to talk about Rybczynski proposition, and this is going to be a subject of our next video. Okay, thank you for your attention.